For generations, humanity has relied on powerful observatories to reveal the hidden universe. Space telescopes like Hubble, James Webb, and Chandra have shown us breathtaking galaxies, exploding stars, and the distant history of the cosmos from beyond Earth's atmosphere. Most people assumed that the next great leap in astronomy would also come from space. Instead, it came from the ground. High in the mountains of northern Chile, beneath some of the clearest skies on Earth, a brand new observatory has captured its very first images. And those images have already surprised astronomers across the globe. This is the Vera Rubin Observatory. Although it has only just begun operating, its first observations reveal a universe that is far richer, more active, and more interconnected than anyone expected. Rather than focusing on a single galaxy or nebula, Rubin can photograph enormous regions of the sky with astonishing detail, creating panoramic views unlike anything ever produced before. At the heart of this achievement is an extraordinary camera. Containing 3.2 billion pixels, it is the largest digital camera ever built for astronomy. Every exposure records an immense amount of detail, covering an area of sky wide enough to fit dozens of full moons. A single image contains millions of stars, countless distant galaxies, and enough scientific information to keep researchers busy for years. And remarkably, these first observations are only the beginning. Within hours of opening its eyes to the universe, Rubin had already revealed interacting galaxies, stellar nurseries where new stars are being born, ancient star clusters, and thousands of previously unknown asteroids moving through our solar system. Astronomers immediately realized they were witnessing the start of a completely new era in sky surveys. Unlike traditional telescopes that spend long periods studying individual objects, Rubin was designed to observe almost everything visible in the southern sky. Every few nights it will repeat the same survey, allowing scientists to compare image after image and detect even the smallest changes across the cosmos. That means exploding stars, wandering asteroids, variable stars, distant supernovae, and entirely unexpected events can all be discovered almost as soon as they happen. Long before its first image reached the public, however, the observatory had already earned legendary status among astronomers. Located on Cerro Pachón in Chile's Atacama region, one of the driest and darkest places on Earth, the facility was built specifically for a mission unlike any previous observatory. Its goal was never simply to capture beautiful photographs. It was designed to create the most detailed time-lapse record of the universe ever attempted. Powering this mission is the Simonyi Survey Telescope, whose advanced three-mirror optical system delivers an exceptionally wide field of view while maintaining remarkable image quality across the entire frame. The telescope's primary mirror measures 8.4 meters across, collecting enormous amounts of faint light from distant objects. Combined with the world's largest astronomical digital camera, the system can observe ultraviolet, visible, and near-infrared wavelengths with extraordinary precision. The scale of each observation is almost difficult to imagine. One photograph covers an area of sky so large that many famous space telescopes would require thousands of separate images to match it. Instead of constructing tiny snapshots of the universe, Rubin captures vast cosmic landscapes in a single exposure. And because the observatory continuously repeats its survey, those landscapes become something even more valuable, a living movie of the changing sky. Rather than producing isolated photographs, Rubin will build an evolving record of cosmic activity over an entire decade. When the first official observations were released, astronomers expected impressive engineering results. What they did not expect was the overwhelming richness contained within the images themselves. One of the earliest mosaics presented an enormous view of the Virgo cluster region, one of the nearest major galaxy clusters to our own Milky Way. Created from well over 1,000 carefully combined exposures, the image revealed millions upon millions of celestial objects. Nearby stars filled the foreground. Elegant spiral galaxies stretched across space with graceful arms winding around brilliant cores. Elsewhere, galaxies appeared to collide, distort, and merge under gravity, while delicate streams of matter connected larger structures across unimaginable distances. Even more astonishing were the countless faint reddish galaxies barely visible in the background. Each tiny point represented another enormous galaxy, many likely containing billions of stars and perhaps countless planetary systems of their own. Yet this breathtaking mosaic represents only a tiny fraction of what Rubin will ultimately observe. During its planned 10-year survey, the observatory is expected to catalog tens of billions of galaxies while repeatedly monitoring the changing night sky. For astronomers, these first images were not the finished masterpiece. They were simply the opening scene. As researchers examined every corner of the data, they found something even more exciting than beautiful pictures.